Hello and welcome to a new video of Web3 hacking and development tips. So in today's video, I'm going to show you, we are going to develop smart contract together in which we're going to block some funds and another person would be able to withdraw the funds blocked in the contract according to some conditions and requirements. Let's take an example of a parent wants to allow their children to withdraw funds, for example, when they reach maturity, when they reach 18 years old or 20 or whatever. So let's dive in and develop our smart contract. So here I'm on remix.ethereum.org, ADE for Ethereum development or smart contracts. So here we have a project. You can just go to create using template and press here create a basic and default project. Okay, so let's get back here. I'm going to create a new file. It's called Trust. As we did always, and I'm going to import specify the license. So let me do this pragma, the version of the Solidity that we are going to use. I'm going to use 0.8.0. It's okay. So in this smart contract, name it TrustFund. We are going to create. What we are going to do, we are going to create smart contract that holds fund and transfer them to other addresses, depending on some conditions. So first thing first, for the smart contracts, I'm going to take an example of a parents want to transfer the funds to their kids. So as a parent, I'm going to create smart contract, and what I need to do at the beginning, I'm going to declare a struct for the kids. I'm going to name it kid. Okay. This struct will contain the amount of money that I want to transfer to each kid, maturity, the time to be able to withdraw the funds, and the Boolean name is claimed if the funds of the kid was able to, after the kid, this to specify if the kid claimed the funds or did not claim the funds. Okay, and one thing, let me show you one thing. What is a struct? Okay, a struct allows you to define your complex type by grouping multiple variables. Here, as you can see, we have struct person, and string is name, and we give it a string for a name, name, and uint age, and then we can declare a person public named Alice. This person would take a name as Alice and for age 25. So that's what we did for the struct. We need amount, maturity, and Boolean to specify if the amount was withdrawn or not for each kid. So the second thing, what I need to do, I need mapping, of course, because we need to map address to the structure kid, and we're gonna name it. Give it a name called kid. Okay. And then, yes, we need an address public also for the parent. So this is our variables declared, and if we need other if we will be needing other variables, we will declare them later. Okay. First thing, let me create a constructor. A constructor, call it parent equal message sender. Please watch the previous videos to see what is a constructor. So first thing, what function do we need? We need to add kids. So, as a parent, I want to add my kids to this smart contract. So first function, I'm going to name it add kid. It's going to take the address of each kid. Uint also, name it maturity. Time to maturity. Okay, gonna make it variable. External and variable. So this function would be able to receive Ethereum. Okay. First condition I want to put require only the parent can call for this function. Parent. Specify a message. Parent, only parent can call function. So far, so good. Now, what we need. We need some conditions thing to add the kids. So what do we need? We need to require, okay, kids, which is our mapping, for kid, which is our address, okay, kids for mapping, which take the address as the mapping here, and the structure assigned to it gonna be amount equal to 0. I'm going to say here kid already exists. So what is this? This line here, it requires the address with the structure amount equal to 0. What does it mean? It means if the amount here equal to 0, I did not put funds for the kid for this address, which is here, event amount. I did not add any funds, any money to the kid, else the kid already exists. I put a condition with the amount because I can add a kid and I forget to add him some money, to put some money for him. So I can add a kid and go again and send a call for this function to add some amount of money. So I only put a condition only on the amounts of money. This is our first condition. Okay, kid. Okay, what's the amount? Equal to 0. Okay. Second thing, so now what we are going to do, kids, which is our mapping, for kid, the address, equal to kid, the structure, message value, which is how much the amount that I want to send, which is the amount, take the message value, because this function is payable, it means I already sent it some Ethereum, which is in the message value, and then block time stamp, the date of the function was called plus time to maturity. Then is claimed is false. Okay, so to this address, I would call this function, would send an address and how many time for maturity. I put some conditions required the parent to be the message sender. The owner is the only one who can call for this function. The kid's amount must be equal to 0. If not, the kids already exist and he has already an amount, not even. And as I said, I put a condition here because I can't forget, for example, to send some Ethereum with a function. So I can call this function again with an amount. And here we're gonna add to the mapping of the address here, the structure kid with the message value, how much money, take how much money, maturity time, how much time to be able to withdraw, and the boolean here is false because he did not claim the money. Okay, so this is for our first function. The second function is the withdraw. The kid would be able to withdraw. 1 second, I would like to make sure of something. Recording, yes, okay. The second function is going to be the withdraw function. Withdraw, okay. Journal, and in this function, what I'm going to do, I'm going to call for the struct for this struct. Later I'm going to explain this line. Storage equal child, whatever, and the kid's message sender. So here in this function, we assigned the message value, the block timestamp plus time maturity and false. And here I'm going to call the kid, the storage of the kid as a child. So I can call each one here later. Each assigned in the structure here later. So I have to put some condition. Require first condition, child maturity must be child maturity here must be block timestamp. So block stamp, else too early to withdraw. So this first requirement function, this first condition, what is going to check the child maturity time compared to the block stamp when the function is called. If this one is too early, it's less than the block timestamp, the kid will not be able to withdraw the funds. Okay. So the second requirement, I'm gonna put a require kid dot amount. What is we name it? No, child dot amount must be more than 0. Else, no funds to withdraw. Okay. And function statement ability can be restricted to view external. Okay. Then what else? What other condition can we put require the boolean get paid already paid. Not the kid, sorry, I'm always mistaking it with the kid because I have the structure called kid. Child, yeah, it's child dot is claimed. So this one, it's initiated to false. If it is different to from false, it means true, which means that the kid is already paid. And let's give it this one. Shield is claimed after he received his money. Must this one take true? Okay. And we need to payable message sender transfer the kid, sorry, the child amount. Yes. So far so good. So what we did here. So everything is okay. So far so good. Okay, let me explain the code. Especially in this function. This function, I believe it's clear. This function here, as we can see, there is kid storage child equal kids message sender. This line retrieves and references the kid struct, which is here, with the address that called the function. Let me type this comment here. So this line retrieves this kid struct with the address that called the function. Okay. So then later we would be able to put our conditions. So require child, this one, which one? Maturity. Okay. So this one already contains the address. Child maturity, the block stamp. So this one, if the block stamp that the function was called superior than the maturity, it's not the time to withdraw the money. Child amount, this one, no funds to withdraw, and if already it's true, claim it already paid. And after that, after he claims, we must update the child is claimed to true. And after all of that, we can transfer the money to the one who initiated the call. So I would like to put one more thing. I want to create some events so we can follow trace our transaction. It first one added. It's going to take address it event time, name it easier, maturity, and event amount. Okay. I would like to create also another event which called withdrawn. The address of the kit and event amount. Okay. And now the first function here, emit. So we said it's going to be the kit, which is the address. Okay. The timestamp, which is going to be where is it? What we do? Kids, kid dot maturity and the message value. This is our first. Here we have to name it. The name, give it the name of the event. Get added. Okay. For this one, before transferring the money, I would like to emit also an event which called event withdrawn. Event withdrawn will take the message sender, which is the address, and the kid dot, or what do we name it? Child. So everything is okay. Here we need to this one. Yeah. So far so good. Let's compile it. Kid maturity amount. God. Here I have to put kid, which is our mapping. Kids, which is our mapping. Here get maturity, and here let's put message value. Message value. Okay, compile again. Everything is okay. Let's deploy it. Take this first address, deploy our contract. This is our contract. So let's add a kid. Let's take a second address. One is still 10 seconds. I'm gonna give him 5 Ethereum. Transact. Initial state only parent. We have to get back to this one. Okay. Transact. Did not put. Yeah, we did not put. So we received the kid, but we received the kid in the mapping. If we take this one, for example, here if we take this address and go to kid, we can see it, but he has no amount. Maturity and Boolean is claimed false. Okay. So because I put a condition here, if only 0 amount, kit is already exist. We can send some Ethereum again with the same address of that kit. 5, let's put transact. You go here again, yes, we can see that it's updated to 5 Ethereum. Let's add another kit. Let's take his address, go back here, 5 Ethereum as well. Avoid any conflict, argue or dispute between the kids. Transact 10, also we give him 10. They are twins, by the way. And here, if we go, it, yeah. So we have another kit, amount of Ethereum, maturity. This is timestamp for to maturity and is claimed false. So normally now 10 seconds are passed. Let's try to withdraw some funds. So the first kid will withdraw some of his 5 Ethereum. So let's do withdraw. The transaction is successful and the kid received his 5 Ethereum. For the other kid, let's do withdraw, and same thing, the other kid received his 5 Ethereum. So in this case, no one can withdraw because it's going to do the mapping to see if the kids exist in the list in the mapping. And the person who is doing the mapping is the parent and only the parent. So this one is external, and you can believe that anyone can call for this function, but no. It will be like it will be reverted because you are not in the list in the mapping, and only the parent who can add a kid to the mapping with this function. So will not be able to withdraw funds. So yes, that's all for this today's video. I'm going to put this code in GitHub and provide you with a link of it. Thank you so much for watching, and I will continue our hard hat and local blockchain soon with the courses soon.